Okay, so here's the engineering challenges I'm up against right now. So it works. It drives, it moves, it not well, but here's the challenges I'm having. So one of the problems is I keep blowing up the battery charging boards. So these lithium batteries have a BMS board inside them, and it's only good for 100 amps. When I bought them, I didn't realize that was the case. I thought they would be, full output, and maybe a limited, the BMS board would handle the charging. But it turns out that it's limiting the input and output. And then when I take off and accelerate with this thing, it takes so much current to make it move that these things are kicking out. So this is it was the wrong choice of batteries. I have to get something else. These ones, I can use these for other projects. I have some smaller 24 volt projects on the, in mind that these will be good for. They're nice and light. They'll be good for a smaller vehicle. Maybe I'll use 24 volts in parallel, so that I'll get, 24 and 24 and put those in parallel. And maybe that'll, work for the next project. But for this, they're not right. So I need to get new batteries. Probably going to get lead acid. Looking around for lithium that have the power rate capability I'm looking for. Difficult to find at a price I'm willing to pay at this point. So a couple of things I need to do. I need to get batteries with higher current output, but I also need to reduce the amount of current that it takes. The other day when I was trying it, I grabbed the handle. I had the speed controller software plugged in. I grabbed the rear end and I held it while I tried to accelerate. And at 160 amps, it blew the battery. So the motor is good for 300. Like, this motor is supposed to be good for 300 amps. The speed controller is supposed to be good for 300 amps. The batteries are the weak point. So I got to come up with better batteries. But I would like to reduce the amount of current that it draws. So it does go pretty fast. It takes a bit to accelerate. Like, it takes a bit to get going, but once it does, it goes very quickly. So I need to gear it down a little bit. So I have these two sprockets. Right now I have a 13 and a 54. This is going to be 10, or this one's 10, and this is 60. So 13 and 54 is a 4.1 to 1 ratio. This is going to be 6 to 1. So I'm gonna get quite a bit just by changing these sprockets over. I don't like doing it. This is going to be, for the chain bending over this, it's going to be noisy. The chain's going to, I don't know. I would rather not do it this way, but this is going to be the simplest choice of repair, or of trying something new. I'm going to gain, 50% more torque and 50% less acceleration, but I think that's okay. Well, actually 33%. So it's going way too fast. I can afford to have it going slower. This is going to make it go slower, but this might not still be enough. At 160 amps, 1/3 of that is still, I don't know, 60 amps, 60 amps or so. So it's going to be 120 amps, still more than what the batteries can handle, but not a problem for the speed controller and the motor. But so I'm going to change the gearing in it, or the sprocket ratio in it, and that's going to be part of it. Another thing I want to do is I want to put smaller wheels on it. So the diameter of these is pretty much the same. These tires are flat, and they need some sort of sealant put inside. They won't hold air properly. So between them being flat and the rolling resistance of these big heavy lugs and the big heavy tires, I want to go to something like this. So it's a little bit smaller in diameter, not much. When this is inflated, it sits up, a little bit higher. This is going to roll easier, right? It's going to look a little bit sillier, right? It's going to be, these wheels are going to sit like this, so it's going to be, it won't look as tough, but I don't care. I want it to be, I want it to roll easily and have, good usability. Right now, it's asking a little too much to have that motor and those batteries to turn these big wheels. I like them. I'm going to keep them. I have to make some changes. This bolt circle in this wheel, this bolt circle doesn't fit that bolt circle. They're both 4 bolt, but they're different diameters. Not out by much, but out by a centimeter or so. So I need to build adapters to mount this wheel, onto that hub. So I'm going to 3D print some adapters for now. I'm not sure if they're going to survive. I'm going to print them at 100%, and you know, not going to have a person on. If they do break while it's traveling, it's going to fall. You know, this thing might collapse on its own, but nobody's going to get hurt on it. So I think I'm going to 3D print them for the prototype. If it works, but they don't survive, then I'll get them made out of aluminum. I know you can buy wheel spacers, but I don't think you can buy them to adapt. So you can buy spacers that move the wheels out, but I don't know that you can get them to move to a different bolt circle. So I'm just going to 3D print something. I'll probably put 2-inch spacers at the back, and not much at the front. At the front, I'm just going to probably just make them as thin as possible and keep the fronts narrower and the backs being wider. Another problem with going to the bigger sprocket is, if you look, we're running out of clearance down here. So these wheels are about the same diameter, so this isn't gonna change much, but we're getting a bigger sprocket in here. So this is gonna be a little bit closer to the ground. Not too concerned. It's not gonna be an off-road vehicle anymore. It's gonna be mostly on asphalt. So it's not going to, you know, I don't think it's going to hit anything, and if it does, I'm going to have to put another sprocket in here. But right now I don't really have room. I'd love to put, you know, have a shaft out here with a sprocket, so the front drives a big sprocket, and then a smaller sprocket behind that drives this. It's very complicated. There's not much space here for it, so I think I would rather avoid that. I'm just going to change these 2 sprockets, lower the rolling resistance of the whole vehicle, and hopefully that's going to lower the current enough to make this thing accelerate better. So some things I've added this light. This beacon on top is going to be hooked up to the remote control. So when it is in remote control mode, and when somebody has control of it, this light's going to flash. The emergency stop is installed. So this switch here, you know, if something's going wrong, if this thing starts to take off by itself, that will kill it. So it's a fast shutdown. I have a new watt meter to install. So this one's well, I blew this one up. So I'm going to replace this because I want this to show me how many amps it's pulling. So that's, you know, without having to have the software hooked up to the speed controller, I want to have a better view of how many amps are being drawn by this thing. This is, of course, the battery switch. Turn the battery on and off. Here's a new weld-on hub for the sprocket. I have to complete the brake levers. I have to put some sort of connector from this cable to these servos. These work okay. They're hooked up. In here is fine. Everything in here seems to be working okay. I had to replace the steering battery. This battery here, I had a 3300 milliamp hour battery. It wasn't charging properly. It was an old battery from an old project, or from an old quad, and it had been discharged beyond its limit more often than I want to admit. So I bought a new battery here. This is 6,000 milliamp hours for the steering to last longer. Right now, with these big heavy tires on, the steering, just sitting here on its own, the steering is hard to turn. Believe it or not, this little motor stalls out trying to turn this steering. So getting the rolling resistance on the front will be better too. And there are a set of wheels for the front. They're about an inch smaller than the back ones for the outside diameter. So it's going to look, you know, a little bit, you know, the back tires will be a little bit higher than the front tires, kind of the way it is now. So we're still going to have that. I built a set of headlights for it. I got some headlights cheap, you know, at my local store. So I put them on a bar, 3D printed a little bracket here. It's not the perfect thing, but it's okay for now. I'd like to change this to this dark blue. I didn't have any dark blue PLA, so I printed it in the purple, and I got to wire them up. This thing's going to wire to one of the relays in the box. Other than that, I mean, structurally it's good. The engineering of it needs some tweaking, mostly lowering the current draw of the entire thing. If it's pulling 160 amps now to accelerate, I would love to get that down to 100, 110, 120. I think at 120 amps, I can find batteries, even lead acid batteries. I'm thinking a marine battery probably. So it's not super high output, and it also has some deep cycle properties to it. So it's kind of a high current deep cycle battery. So I'm probably I gotta go to the local battery place, um, talk to those guys there, see what they can suggest. Right? Maybe it's time to bring in the experts on the batteries. But other than that, it looks okay. I might put fenders on it just to kind of give it that more, give it a more vehicle type look. A couple of other options, a few things I have still to bolt to it. The RFID card reader I want to put on it so that we can. I have a little bit of control over how fast it goes for whoever's driving. I'm going to spend some time 3D printing the adapters for the wheels. That'll be the kind of the big thing now, is getting the wheels mounted. It might take me a while to find batteries. It's going to be some money again for batteries. I spent enough money on these already that I would like to not have to spend a lot of money on some batteries. But even four deep cycle, decent deep cycle batteries, 4 of those is going to be several $100s. So I'm trying to avoid that a little bit. Okay, so I guess that's it for now. Some engineering challenges to solve, and some coding to do. I bought the new brain for it, the Jetson Nano, so I want to start figuring out how that works. So that'll be some inside work, some 3D drawing, inside work, and I'm going to put this away for a little while, just for till I come up with it, till I solve the battery problem. So when I get to that point, I will let you know.